Water pollution, which is caused by different impurities in the water such as microplastics, remains a major environmental issue that affects the world in different aspects. It's estimated that 8.3 million tons of plastic are discarded in the ocean throughout the world yearly, and in the Philippines, an annual amount of 0.28 to 0.75 billion tons of plastic enters the oceans from coastal areas in Manila Bay. This makes the Philippines one of the world's worst contributors to marine waste. Good day, I am Jadel Mira Tadaya, and this is my research study entitled ReMSea, Removal of Microplastics in Seawater Using Magnetic Carbon Nanotube-Embedded Robot. Related studies have presented a solution to this issue by synthesizing magnetic carbon nanotubes or MCNTs. These possess super paramagnetic characteristics, pi-electron conjugation, complexation, and electrostatic interactions, which aid in the absorption of plastics in seawater. Although MCNTs are successful at absorbing microplastics in aqueous solutions, retrieval was accomplished by using magnets to collect them after they were utilized. Because of their small size, manually collecting them after use will be difficult in seawater. To address this issue, the researcher aims to utilize a surface water remote-controlled robot embedded with magnetic carbon nanotubes or ReMSea. ReMSea consists of GPS sensors similar to cars for its navigation and data collection without the use of an internet connection, and an HGSR04 ultrasonic sensor and LiDAR module for obstacle avoidance. It is also a solar-powered robot, making its energy source renewable and efficient. The main body of ReMSea is made out of recyclable materials, polyvinyl chloride or PVC, through which it will be molded and cooled to create the robot's casing and ensure its waterproofing abilities to protect the components. MCNTs will be embedded in the robot through galvanized magnetic plates which will be placed inside the lower compartment. A metallic mesh will cover it. The robot will have a compartment similar to that of a chamber containing MCNTs in which water will be able to pass through a hole. The system of the robot includes these components such as Raspberry Pi 3B+, Pi 3 enclosure, GPS module, Pi camera module, LoRa module, L298N dual H-bridge motor drive, DC motors, and other related components for connections such as these. To interface the GPS module, the GPS antenna will be connected to the GPS module. The global positioning system fixed data string will allow the latitude, longitude, and time to be recorded. The module will also be visible on Google Maps. To interface the camera module, the module's ribbon cable will be inserted through the camera port of the Raspberry Pi. The video feedback will be streamed over the web via Flash. To interface the motor driver, two motor drivers will be connected to the two motor slots of the L298N module. Female type jumper wire will be connected to the motor controllers, and to control the polarity of the motor, these are the other connections needed. For the power supply and battery, these are the connections needed. The recommended input voltage and current are 5 volts and 2 amperes. At least 10 wattages are needed. Considering other external factors, a solar panel producing 12 watts per hour will be utilized. Lithium-ion batteries will provide a backup power supply when the solar panels cannot produce enough power. To control the robot, LoRa technology will be employed. The robot will utilize the radio head packet method where the microprocessor receives data from the sensor and sends it into the air through the radio module, which the LoRa gateway will pick up. Raspberry Pi will be connected to a desktop and the SPI will be enabled. After several tests of the robot, the attached MCNTs will be transferred to a container to separate the adsorbed microplastics using FTIR spectroscopy to determine the collected microplastics fiber size, amount, and chemical composition. ReMSea will be evaluated with 5 dependent variables included in the experimental design: the amount and type of microplastic collected, buoyancy, waterproofness, and power efficiency of the robot. Here are the setups of the mentioned parameters to be tested. The robot is expected to function efficiently and effectively in absorbing and collecting enormous amounts of microplastics. ReMSea will aid the environment through cost-effective utilization. This will improve community health, help rebuild marine ecosystems, and help urbanize impoverished areas to broaden their use of water cleaning devices. Without this robot, it would be next to impossible to eradicate microplastic pollutants due to their microscopic size and complex nature. They say, what you can't see doesn't hurt. But in this case, what we can't see will cost us not just the marine ecosystem, but our own very lives, as well as the next to come.